This lesson is on section R.4, which is about factoring. So this R.4 is a review section, so you should already know how to factor, so this will be just a brief review. Now the first topic in this section is GCF, or greatest common factor as we know it. So the greatest common factor is the largest factor that two or more terms have in common. So if I want to factor, let's see, the instructions tell me factor out the GCF. Factor out the GCF. This means I want to find what is the largest factor that however many terms there are in the problem have in common, and then factor it out or figure what times this one factor will give me my stated problem. So if I want to factor out the GCF between 6a squared and 18a to the fourth, I'm going to look at each term and find if there's a numerical GCF and also a variable GCF. So when I look at the factors of 6 and 18, you will always start with 1 and work your way up. Once the factors start to repeat, you know you've listed all the factors. You don't have to worry about missing any and getting the answer wrong. So the factors of 18, 1 and 18, 2 and 9, 3 and 6. Then when I look at the factors that they have in common, they have a 1 and a 2, a 3, and then 6 is going to be my largest. So 6 is going to be the numerical GCF. Then when I look at letters, I look at every term and determine if there's a letter or letters that appear in every single term in my stated problem. If there is, I take that letter, and then I'm going to use the smallest exponent for each letter that's common to every term. So for this problem, A is in both terms. Its smallest exponent is a 2. Okay, now once I have found the GCF, or the greatest factor that the two terms have in common, I want to know what was multiplied times this one term to give me my stated problem. So I want to know what times 6a squared gives me 6a squared, and that would be 1. And then what times 6a squared would give me 18a to the fourth, and 6 times 3 makes 18, and a squared times a squared gives me a to the fourth. So if you'll recall your exponent rules, to add exponents, all right, so then this would be my answer. All right, let's take a look at another. Let's say we have 14 x cubed y squared minus 28 x squared y cubed plus 21 x squared y squared. And I want to factor out the GCF. So when I look at all three terms, I have to consider them all. The numbers 14, 28, and 21, the largest factor they have in common is a 7. Alright, so that's my numerical GCF, but remember I also have to consider the variables. So when I look at all three terms, they have an x, and they all have a y. Then I find the smallest exponent for each letter. So for the x, the smallest exponent that I see is a 2. And for the y, the smallest exponent that I see is also a 2. So I'm going to give my x a 2 and my y a 2. So 7x squared y squared is my GCF. Alright, now I want to know what times this factor gives me all my other terms. So what times 7 makes 14 is 2. I need x cubed, but I only have x squared, so I need one more x. I need y squared, and I have y squared, so I don't need any more y's. Alright, for the next one, what times 7 makes 28 is 4. I need x squared, and I already have x squared, so I don't need any more x's. I need y cubed, and I have y squared, so I need one more y. Alright, now what times 7 makes 21 is 3. I need x squared, and I have x squared, so I don't need any more x's. I need y squared, and I have y squared, so I don't need any more y's. So that would be the end of my problem.